when they're talking about a 1 in 12 ramp, when you're talking about 1 in 12, what you're saying is that it has to be in the ratio of 1 is to 12. So as an example, I could make a ramp 24 across and 2 up. Is that still a ratio of 1 in 12? It is. Because what's 2 divided by 24? 1 in 12. What happens if we did 120 and 10? Is it still 1 in 12? Yeah. Just be clear about that. Now, the opposite is 1. The adjacent is 12. So what function are we going to use? Tan x, 1 over 12. We're then going to tan inverse 1 over 12. And when we tan inverse 1 over 12, 4 points. Is it 76? Yeah. Okay. We get now. See the way I got the wrong answer? See the way I got the wrong answer, guys? You know what happened to me there? My calculator doesn't say D on top, it actually says R. So it means I'm in the wrong mode. I go shift, setup, I go to my degrees or your angle unit, I try again. And there I get my 4.76. So you have to be careful that your calculator is in the correct units. All good? Next thing. Remember, we're allowed to have it flatter, but we're not allowed to have it steeper. Does that make sense? If the ramp is any steeper, that guy in the wheelchair might struggle to get up the slope. And when they're coming down, they might end up going dangerously fast. Okay, so here's what we're doing next. Does this ramp fit recommendations? Well, this time the opposite is 53 and the adjacent is 640. So we're going to tan inverse what? 53 over. And we get an angle of 4.73. Yeah, perfect. And does 4.73. Now, no, that's the correct answer, okay? But what does the question actually tell me? Yes, because angle is smaller. Because angle is smaller. All right? If the angle was larger, you'd say could be dangerous. Okay. Move on, next one. The next one's handy. Very handy. Okay. The next one is you have a height of 42. Does everybody remember that it has to be 12 times bigger? Everybody knows it has to be 12 times bigger? Multiply it by 12, 504 centimeters, because it has to be 12 times bigger. Now, there is another way of doing that. I'll show you now. Okay. What angle did we say this was again? 4.7. Tan 4.76 is 42 divided by x. Bring the x upwards. So x tan 4.76 equals 42. What will I do with the tan 4.76? Put underneath. Now, because we rounded off, we might not get exactly the same answer, but we'll give it a go. 42 divided by tan 4.76. What do we get there? 504 as well. So it didn't matter what way we did it, we get the same answer. Any questions? Let's make the small triangle first. Everybody see the small triangle? So see the way I'm using, put it in yellow for you. Everybody see the yellow triangle? That's what I'm using. So what two sides do I know? Opposite and. So what's a tan A equals? Over 5. Tan inverse it. What do we get? Who got 17.2 degrees? Why did you lose a mark if you did 17.2 degrees? Nearest degree. Ray, the reason why a tan inverse is it's an angle question. A is an angle. So angles require you to tan inverse, cos inverse, or sine inverse. Everybody cool with that? Yeah. Shh. Next thing, we're asked to find the height of the mast. Now look at this, guys. Listening? Height of the mast. So look, check this out. Red line from here to here. Red line from here to here. Red line from here to here. Does everybody see the big red triangle? Everybody see the big red triangle? Okay. The big red triangle is 23 across, isn't it? We want to calculate x, which is the height. We know the angle is 17 degrees. What two sides do we know? We know 23 and we're looking for x. That's opposite and. So what do we get? Tan 17 is x over 23. What type of question is this, guys? Angle or length? So there's no tan inverses this time, right? What do I do to 23? What's 23 times 17? 7 meters, is it? To the nearest decimal. And to the nearest decimal, 7.03 rounds off to 7. Still 7.0, lads. Who got that one out? 7 on the money. I think it's 3B, is it? Or 2B? 2B. Okay. During a trigonometry lesson, a group of students wrote some statements about trigonometry. The value of trigonometric functions will never be greater than 1. Okay. The answer is false. Let me explain. What's tan 50? And what's tan 70 in your calculator? Any tan over 45 degrees is bigger than 1. Lads, is that dispel that myth? Excuse me, gents, we all good? That stops that outright, doesn't it? That tan can be bigger than 1. Next one. Do you think that 2 is correct? If the angle is doubled, then the trigonometric function will also be doubled. Most of you did well with this. Pick any function you want. I'm going to pick cos 30, which is 0.87. Then I'm going to double the angle and get cos 60. And what's cos 60? And what I'm basically saying to you guys is, the answer is no. Reason being, doubling angle doesn't double value. Yes. When you are explaining, unless you explain it ridiculously well, you should always put an example to get full marks. Examples are the easiest way to do it. So I thought you wrote very well, but you're just lacking, I think, 4 out of 5 sometimes, was it? Yeah, just if you put that example in, you really nail it home. Yes, Ray. Correct. What does tree say? All right. If the angle gets bigger, the value gets bigger. That is false. And yeah, this one you only need one thing. Right. Just use any cos value and you're sorted. Cos 30 is what? 0.87. And up that to cos 60 with this. And you can clearly see that cos gets smaller. Cos value gets smaller as angle gets. Yeah. Do you see that, lads? You don't need a big, massive explanation. You just get it in that quickly. You were talking about that time I did the circle and closed in and went up. Yeah. Fair play to you for trying to do that. Oh, gets smaller as angle gets bigger. Thank you. Show how a right-angled triangle in which the sides are equal to 1 unit can be used to find 45 degrees in short form. Okay, this is a lads. Now, would everybody agree with this triangle here? Would everybody agree that it's 45 degrees? Well, how do we know it's 45 degrees? They're equal to each other. You know what I'm saying? Because they're equal to each other, it means that the other two angles have to add up to 90 degrees, and both the angles are the same size, 45 degrees. Next here, we're going to do Pythagoras' theorem. X squared equals 1 squared plus 1 squared, x squared equals 2, and therefore x equals root 2. You happy enough with that? Now, finally, using the 45-degree angle in the bottom left, marked in blue, the yellow sides, sine, what does sine want you to use? Sine wants you to use opposite and hypotenuse. Sine 45 is in fact 1 over root 2. Hey guys. Yo. Now, lads, you ready? 3 significant figures. Let me give you a revision on this. You ready? Here we go. How many significant figures in 52,000? How many significant figures in 52,000? 2 significant figures. How many significant figures in 52,001? 5 significant figures. If the zeros are sandwiched in between 2 regular numbers, they're considered a significant number. So 52,000, because it has zeros at the end, it only has 2 significant numbers, and 52,001 actually has 5 significant numbers. Let me try more examples. So you'll get it sooner or later, right? Let's try another example. And we would have known this back in the day. 729,000. How many significant numbers in the green one? 3. The 7, the 2, and the 9. Because they all come before the zeros. Now, how many significant figures if I do 729,008? How many significant numbers now? 6, because they're sandwiched in between, right? How many significant numbers in 729,800? 4, because the zeros at the end don't count. Now we're going to do decimals. You ready for this? Shh. How many significant figures in 0.08? 1. How many significant figures in 1.08? 3, because it's sandwiched in between. How many significant numbers in the following? Shh. 1. How many significant numbers in this one? 4. How many significant numbers in this one? 3. Okay. Yes. Okay. Now, lads, can somebody who got full marks in this tell me the answer for this one? What do you get for costs? Costs 0.866. Now, the deal is cos 30 is actually the same as sine 60. What's cos 40? 0.1? 766. And cos 40 is actually the same as sine 50. And then what's cos 50? What's cos 50? 643 rounded. 643. Somebody's got A out 10 because you put in 642. Should have been 643. And a lot of you's got 6 out of 10 because you didn't do 3 decimals. You did 2 decimals or 1 decimal. Now, what do you conclude from the results above? Okay, let's do this. That cos Uh, cos 60 equals sine 30. Yeah, yeah, yeah. Sine 30. So, any once once the angles add to 90, then sorry, once the two angles add to 90, once the two once the two angles add to 90, then cos will equal. Does that make sense? So cos 60 equals sine 30, cos 70 equals sine 20. Yes. All right. That's it. Now, lads, last one. Sorry, second last one. All you have to say for this is 42. Just use cos 48. Once the two parts add to 90, you're all good. Okay. Last question. Thank you, sir. Okay. We want the opposite and we know the adjacents. So once again, we're going for tan. Sorry, Sato used tan so often in this test, so we really thought there would have been more options. Now, bring the 700 up and multiply by tan, 20.8. And what do we get for that then, guys? 266, the nearest meter. Now, lads, most of you guys opted to use Pythagoras' theorem on the next one. And we found out what x is. So we go x squared equals 266 squared plus 700 squared. And what happens when we add them together? Who got, was it 56,076, was it? Will you do it now? Tell me what you get. Or anybody who got 5 marks? Yeah. Square root that. Square root to get your answer. Okay. Full marks, yeah or nay? Why? Lastly, lastly, your car goes, your car goes 748.8. E, EB. Look, your car goes from here to here. So it does 748.8 meters. And how long does that take in seconds? Not minutes, seconds, lads. Seconds. 210. Distance over time. 748.8 divided by 2.10, and what you get? 3.6 meters per second.